Alrighty, so here is the last section in chapter 11 where we are applying the distance and midpoint formulas. Now, distance formula is derived from the Pythagorean theorem, which we learned in section 11.4. And if you look at our graph here, as you can see, what we're trying to do is we're trying to find the distance from of the blue line. And we can do that by taking this, using the coordinates and subtracting them out to get the distance formula. And so, as you can see, this happens to be a right triangle. And if we remember what the Pythagorean theorem is imagine that this is A, and this is B, and that's C. And we learned that the Pythagorean theorem is A squared plus B squared equals C squared. And just by looking at the coordinates here, we can count that it's 1, 2, 3, 4, 5 units. So here we have A equaling 5 units. B, we have 1, 2, 3. So B is 3 units. So this is where we see that if this was this point right here was point C, we can see that AC equals 5 and then BC equals 3. And then all we have to do is apply the Pythagorean theorem where 5 squared is 25, 9 squared, or 3 squared is 9, and 25 plus 9 equals, what, 34? So the distance from C would be the square root of 34. And I think if we were to remove this here, yeah, this is where that's where that comes from. So, but there is a general equation that'll help us use the distance formula. And, oh shoot. So if we have 2 points, which are x1 and y1, and x2 and y2, by using the distance formula, we can say that D equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, it doesn't matter which one you use as your x2 or y2. It's important that whatever coordinate you use first in the x portion of the formula, you use the same for the y. So if you were to say you were to use this x first here, it's important to remember to use that y as your first one too, or else you will get the problem incorrect. So the distance formula helps us when we have coordinates. So let's do an example. So if we're given 2 coordinates, for A we have -3, 1, and 2, 3. So what we have to do is we have to now apply the distance formula. So we have D equals the square root, and what I'm going to do is I'm just going to write up on top x1, y1, and x2, and y2. So I got x1, y1, x2, y2. This will kind of help me figure out which numbers go in which spots to substitute into the formula. So my x2 is 2 minus a negative 3 quantity squared plus my y2 is 3 minus my y1, which is 1 quantity squared. So now we have d equals the square root of, this is plus plus, this is 5 squared plus 2 squared. And 5 squared ends up being 25. And 2 squared ends up equaling 4. And d ends up equaling the square root of 29. If you wanted to simplify it, it's something like 5.39 units. Okay, let's do another. So I have coordinates here. I got 10 and 10, 5, and 6 and 2. So I got x1, y1, x2, y2. So I got d equals square root. Okay, let's go 6 minus 10 squared plus 2 minus 5. So if I simplify this, we got what? Negative 4 squared plus negative 3 squared. Okay, so d, negative 4 squared ends up equaling 16. Negative 3 squared equals 9. 16 plus 9 is d squared root 25. And d ends up equaling 5. So the distance is 5. Not so bad. This part here is where it gets a little bit more complicated. It's when you have a missing coordinate and you must find the distance, you must find the coordinate once we, let me try that again. We're trying to find the missing coordinate of an endpoint of a line segment given its distance. That's better. All right, so we want to find the distance between what, for example A, the distance between 3 comma negative 5 and 7 comma B, which we don't know what B is, but what we do know is that the distance of this line is 5 units, and we want to find the values of B. And here's where we find out where we got 2 units. So right here, where I'm highlighting, is coordinate 3 comma negative 5. Okay, and this little dotted line right here, that is where x equals 7. Okay, so our point is going to be somewhere on that dotted line. And the thing we know is that we know that the distance of d is 5 units. So, but it could go from either direction. It could be 5 units this way or 5 units this way. So that's where our b could be here and our b could be right there. So we don't know where exactly that is at this moment, but we can find out. So I would like to get some more room here. So I'm going to extend this a little bit, move this down, and give me some room to work with. Good. So we can still use the distance formula. So I'm going to put, this is my x1, this is my y1, this is my x2, and this is my y2. Okay? So instead of having d, I'm going to write 5 because that's what our d equals to. The square root of 7 minus 3 quantity squared plus b minus a negative 5 quantity squared. So I have 5 equals the square root. 7 minus 3 is 4. So we got 4 squared plus, we got b plus 5 quantity squared, because this is a plus plus type of situation. Okay. So now we have 5 equals, we got 4 squared, which is 16, plus, now we have to factor out our b plus 5, which is b squared, plus 10b, plus 25. Okay? So if we simplify this more, we got 5 equals square root b squared plus 10b plus 41, because I'm just combining this and this. Now we're at a point where I can't simplify it anymore in the square root. So what I'm going to do is use some tools that we learned from previous sections, and I'm going to square both sides. So now I have 25 equals b squared plus 10b plus 41. Now what I want to do is I want to set the one side equals 0 and solve for b. So now I have 0 equals b squared plus 10b plus 16. And now I'm going to factor them out. So I have parentheses. I got b, so it's plus plus. And the sum of 10 and the product will be 16. So 8 plus 2 equals 10. And 8 times 2 will equal 16. So now if I use the zero product property, I can know that b will equal negative 8. And I know that b will equal negative 2. Okay. So I found my two values for b. So the coordinates that if we have a 3 comma negative 5 and a distance of 5, it'll be 7 comma negative 8. And 7 comma negative 2 will give us that result. So let's see, let me give some room for this one, just like I did for that. So now I have, same thing, I have a distance between b comma negative 6 and 5 comma and negative 5 comma 2, which the distance is 10. I need to find the values of b. So using the distance formula, let's put 10 as my d. And for this one, I'm going to put b first, minus a negative 5, because I want my b to be positive, quantity squared, plus, now I have to use negative 6 first, minus 2, quantity squared. Doesn't matter which sets of x and y you use first, just as long as you're consistent. Okay? So I got 10 equals square root of b plus 5, quantity squared, plus a negative 8, quantity squared. Drop this down. So let's factor this out. We got b squared plus 10b plus 25, and negative 8 squared is 64. So now I have 10. Now I'm going to combine my 25s together. We got b squared plus 10b plus 89. So now we're at a point where I can't simplify anymore inside the square root. I must square both sides to get rid of it. So now 10 squared is 100, and the square root of b squared plus 10b plus 89 will just be b squared plus 10b plus 89. So I'm going to subtract 100 to both sides, set equal to 0. B squared plus 10b minus 11. And now I can factor it out. So now I have 0 equals parentheses. I got b. I know it's a plus and a minus. And I think it's going to be a positive 11, negative 1. So if I use the zero product property, I have b equals a negative 11, and b equals, nope, that's just a positive 1. And so the coordinates that'll be correct would be what, negative 11 comma negative 6 and positive 1 comma negative 6. So that's how you use the distance formula. Next is the midpoint formula. So the midpoint formula, which is represented here as m, what they're trying to find is the line segment. I don't know why this is, I'm sorry, this is, I don't know why it's overlapping like this, but it's the midpoint of m of a line segment with endpoints a and b at x1 and y1. That's what's written as written at right here, and x2 and y2. So the midpoint formula is x1 plus x2 divided by 2. That gives you your x coordinate, and y1 plus y2 divided by 2 will give you your y coordinate. So it's the average of the x and y values. So if I were to do some examples, we need to find the midpoint of the given endpoints. So I have a distance of negative 3 comma negative 1 and 7 comma negative 5. So I'm going to find the midpoint, which is m equals, so I have negative 3 plus 7 divided by 2, comma, negative 1 plus a negative 5 divided by 2. So negative 4 plus, that's 4 divided by 2. This is negative 6 divided by 2. And so the midpoint would equal 2 comma negative 3. Let's try another. So here I have m equals, so it's 2 plus 20, so those are my two x values, divided by 2, comma, 12 plus 15 divided by 2, which those are my y values. 2 plus 20 is 22. 22 divided by 2 is 11. 12 plus 15 is what, 27. 27 divided by 2 is 13.5. Okay, not so bad. But there is one that gives maybe a little bit more complex, is if we're given an endpoint of a line segment, and also we're given the midpoint, well, I want to find the distance of the other endpoint. So we can still use the distance formula. We can still use our m is x1 plus x2 over 2, comma, 1 plus y2 divided by 2. So here we're given the x1 and the y1. The only thing is we're trying to find what x2, we don't know what that is, and we don't know what y2 is either. But what we do know is we know that if you were to take negative 10 plus x2 divided by 2, you'd get a result of negative 8, because that's the x value of our midpoint. And if you were to take 4 plus y2 divided by 2, it would give you a negative 4. So now all we're doing is we're solving for our x2 and our y2. So let's do the x2 first. First off, I'm going to multiply both sides by 2. So that gives me negative 10 plus x2 equals a negative 16. I'm going to add 10 to both sides. It gives me x2 equals a negative 6. And for our y value, so I'm going to again multiply both sides by 2, so it gives me 4 plus y2 equals a negative 8. I'm going to subtract 4 to both sides, it gives me y2 equals a negative 12. So the other endpoint equals negative 6 comma negative 12. And if you wanted to check your answer, you could use this as your endpoint and this is your endpoint. Use the distance formula and you should come out with negative 8 comma negative 4. Let's try this again. So here's my x1 and here's my y1, and this is my midpoint for my x value here, and then my midpoint for my y value is here. So if I were to go negative 1 plus x2 divided by 2, it would equal 2. And if I were to go 9 plus y2 divided by 2, it would equal 4. So solving for the x2, multiplying both sides by 2 will give me negative 1 plus x2 equals 4. And adding 1 to both sides will give me x2 would equal 5. Doing the same thing for my y value, and multiply both sides by 2, so 9 plus y2 will equal 8. Subtracting both sides by 9, my y2 will equal a negative 1. So my other endpoint will be coordinate 5 comma negative 1. And if you were to use this as an endpoint, this is an endpoint, using the midpoint formula, you should get 2 comma 4 for your answer, just to double check. And that is how you apply using the both the distance formula and the midpoint formula. So I hope this helps. Till next time.